down.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Hey, good evening teachers, parents, and all the wonderful students. Welcome to Pusat Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you ready for today's lesson. Before we proceed, let's begin our section by reciting a prayer for Muslim. The non-Muslim may pray according to your own religions. Okay, let me introduce myself. I'm Teacher Kong from College Matrikulasi Perak, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So, are you ready? Let me introduce our teacher for today's lesson. We have Cikgu Tang from College Matrikulasi Selangor. Okay, we are now live on Cikgu Tang's channel. Please support her channel by clicking subscribe now. The topic of today's lesson is Atomic Structure Part 2. And together with us, we also have Cikgu Shannon from College Matrikulasi Pulau Pinang, who is control host, in charge ensure the smoothness of our lesson on technical support. So before we begin, I have few reminder to all of you. First, please pay attention to our lesson. Stop chatting and use the chat section wisely. Number 2, regarding certificate link, the link will be given at the end of our lesson. Please use eDidik account when you fill your particulars and make sure to listen to the passcode given by the presenter or by me from time to time and fill in the form within the time limit, which is 30 minutes. Okay, so now I would like to tell you all the first passcode. A3. 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 Okay, so without further ado, let's welcome Teacher Tang.
Hey students, so I'm Teacher Tang from College Matrikulasi Selangor. So I have 8 years of teaching chemistry. So these are my group members for the pre-U chemistry. For the pre-U chemistry. So we have Teacher Vivi Lau, me, Cikgu Shannon, Cikgu Mawar, and Teacher Kon. So all of us led by Cikgu Shannon. He is our leader. So besides chemistry pre-U, we also have mathematics pre-U led by Teacher In, and the biology pre-U led by Cikgu Faiza, and also the physics pre-U group led by Teacher Rosmaya, and then the accounts and economy pre-U group led by Madam Fizi. Okay, so now we shall start with our topic today, atomic structure. So this afternoon, I'm going to focus on Bohr's atomic model. And so basically, I'm going to cover, so what is Bohr's atomic model? So explain the existence of the energy levels in an atom, so hydrogen atom, and then calculate the energy of an electron using the formula, and then describe the formations of line spectrum of hydrogen atoms, illustrate the formations of Lyman, Balmer, Paxton, Brackett, and Tiffin series, and calculate the energy change of electron during transition, calculate the photon energy involved, and then also perform calculations using Rebut equations. So last week, Teacher Vivi Lau already introduced. So Bohr's atomic model basically is proposed by Bohr. So when Bohr proposed this atomic model, he used hydrogen atom as the model for him to propose this model. And then in the Bohr's atomic model, basically Bohr divides the hydrogen atom into two parts. So the first part is the nucleus. which consists of proton and neutron. And outside the nucleus
Hello,
consists
Cikgu
of,
Tang.
yes?
Okay, the sound is not clear. Okay, a bit blur. Maybe you can try alternative way. Yeah,
Oh, okay.
try testing. Okay, you try testing 1, 2, 3. See whether clearer or not. Teacher Tang. No sound. No sound. Unmute. Teacher Tang, try unmute yourself. I can't hear you, Teacher Tang. Can't hear you. Let me try again.
Okay, can you hear me?
Oh, yeah. Yes, can. Okay, clear. Okay, Teacher Tang, you may continue.
Okay, sorry about that. Sorry about that.
Okay, let's continue again, student.
Okay. Okay. So shall we continue? So Bose atomic model. So last week, teacher Vivi Lau already introduced Bose atomic model. So this Bose atomic model proposed by Bose, and then when he proposed this model, he used hydrogen atom as the model for him to propose this model. And when Bose proposed this atomic model, he basically divided atom into two parts. So the first part is the nucleus, where it consists of subatomic particles like proton and neutrons. Okay, and outside the nucleus consists of fixed orbit, where electrons move within the fixed circular orbit. Okay, so he assumed that electron move in the circular orbits around the nucleus. And basically, when Bose made this atomic model, he made this model, and this postulate is basically assumption. He said that the electron in a hydrogen atom can only be in a permitted orbits of specific energy. So what does this mean? So basically, Bose meant that the electron can only be in a specific orbit. So these are orbit. So means that electron can only be in this orbit, anywhere in this circular orbit. Okay, but it cannot be in between here. Cannot be in between the orbits. Cannot. It must be in this permitted orbit. Okay, must be in this permitted orbit. The line, the circle line I draw representing the circular orbit. So electron can only be in the permitted orbit. Okay, and this permitted orbit having specific energy. Okay, so each of these orbit has its own energy. Okay, therefore, we can illustrate the energy of the orbit in an energy level diagram. The orbit that is closest to the nucleus is energy level 1, okay, with a certain amount of energy. So when illustrate in the energy level diagram, so the lowest one, this one, n equals to 1 is corresponding to this orbit, okay, nearest to the nucleus, okay, and then followed by n equals to 2, energy level n equals to 2, so representing the second orbit, so this second orbit, okay, so this n equals to 2 corresponding to the second orbit, and then the third orbit n equals to 3, so is corresponding to this, okay, and n equals to 4 corresponding to this orbit, the fourth orbit, okay, and so on, okay, and then when we draw the energy level diagram to represent the specific energy of the orbit, so we can see that when we draw the line getting closer to one another. You see this one space, a lot of space between. So the space between energy levels getting closer. So why? It is because as the orbit further away from the nucleus, they get closer together. Can you see that? Between n equals to 1, n equals to 2, largest spacing between them. And then between n equals to 2 to n equals to 3 getting smaller, n equals to 4, 3 and n equals to 4 getting smaller and getting smaller and smaller. Okay, so it's because as further away from the nucleus, the orbit, distance between each of the orbits getting closer. Therefore, when we draw the energy level in the energy level diagram, we draw the spacings between getting closer and closer up to infinity. Okay, so again, the first postulate, the electron can only be in the permitted orbit, and this permitted orbit having specific energy. So this is first postulate. So just now I already told you, so each of this orbit having specific energy. Okay, so basically, so having specific energy, and then Bose actually came up with formula to calculate the energy of the electron in that particular orbit, in a particular orbit. So this is the formula. Okay, so this is the formula for Bose to use to calculate the energy of an electron when it is at a particular orbit. Okay, so basically, so electron when occupying, okay, so first postulate, electron can only be at permitted orbit. So when electron at permitted orbit, because this permitted orbit having specific energy, so therefore the electron in the permitted orbit also having specific energy. Therefore, sometimes you can see some book saying that the energy of electron is quantized. It is because electron can only be in the permitted orbit, and when it is in the permitted orbit, so it has specific energy because the orbit having a certain amount of energy. So basically, so we can illustrate the whole thing by assuming we are stepping up the staircase. Okay, like for example, this is a staircase. So the first level here, the first step here is about 0.1 meter from the ground. So the second one is 0.2 meter from the ground. And the third one is 0.3 from the ground. The fourth one is 0.4 meter from the ground. And the fifth one is 0.5 meter from the ground, and so on. So for example, now I'm like the electron, so I'm standing here. Okay, so when I stand here, okay, the second step, okay, so me standing here will cause me to have certain gravitational potential energy. So you learn physics, so the gravitational potential energy of me being standing on the second step, so basically it will be equal to mgh. So this h is corresponding to this height. Okay, and then me, when I walk down, I walk up the staircase, it is not possible for me to stand in between 0.3, not to be able to stand in between this. Okay, 0.3 and between 0.3 and 0.2, not possible for me to stand in between this. I can only be here, third step, or the second step, or the first step, fourth step, or fifth step. I tak boleh stand in between. Like for example, 0.32 meter, 0.25 meter from the ground. Not possible. Okay. So as electron in the atom, they can only be moving in a fixed orbit. Okay, and that orbit having specific energy causes the electron to have specific amount of energy. Just like me standing on the like for example second step of the staircase. So I will have this amount of energy. Okay, and this h is corresponding to 0.2 meter. Okay, when I stand here, the third step, yeah.
Teacher Tang, there is one question. Aina Maisara asked,
yes.
that means that the value of RH means the Ribot's constant is constant, right, madam?
Oh, yes. The RH is a constant. Don't worry about this first. We are going to look at it in detail. Okay. So madam, standing at the third step, so I will have the potential energy of this. Okay, Peter. Okay, so specific, very specific gravitational potential energy that I'm going to have. So now we shall move on to see how do we calculate the energy of electron when it is at specific, when it is at the fixed orbit. Okay, so shall we look at okay, so before that, so shall we look at the second postulate? So the second assumptions, the Bose-Mack is when an electron is in a permitted orbit, it is in an allowed energy state and it does not radiate energy. So means that it does not lose energy. So means that when electron, it is in moving around its own fixed circular orbit, it will not lose energy. Just like madam, okay, so madam, be in the second step, so I can be here, be here, be here. As long as I'm in this second step, okay, I will have this gravitational potential energy, but I will not lose any gravitational potential energy because I'm not moving between the steps. I'm just at the second step. Okay, so just like the electron, when it is moving in a permitted orbit, that particular orbit, it will not radiate energy, means that it will not lose energy. Therefore, it will not spiral into the nucleus. It will not be attracted into the nucleus. Just like me, if I'm moving at the second level, okay, I will not lose any energy, gravitational potential energy, and therefore I will not fall to the ground. Okay, so now we shall look at how to calculate the energy of the electron when it is at specific orbit or at specific energy level. So for example, if the electron is at first orbit with energy level n equals to 1, so how do we calculate the energy of electron at n equals to 1? So basically, we just need to use this equation. The Bose use these equations to calculate the energy of electron at that particular orbit. So, and the particular orbit now is n equals to 1. So the n here referring to the energy level or the orbit. So if it is the first orbit, n equals to 1, then here will be 1. Okay, and then RH here is a Ribot constant. So because this is energy, so this is the Ribot constant that we need to use. 2.18 times 10 to the power of negative 18 joule. Okay, and the n here again refer to the energy level. So it is at the first orbit, therefore energy level n equals to 1. Okay, with that, then we just need to substitute into the equation to get the energy of the electron at first orbit, energy level n equals to 1. So this is the energy of electron when it is at first orbit, n equals to 1, energy level n equals to 1. So the first orbit is energy level n equals to 1. And this is the energy of electron when it is at that particular orbit, n equals to 1. So now we move on to look at if now the electron is at second orbit, the energy level n equals to 2, then what will be the energy of the electron? So now it is at the second orbit, so energy level n equals to 2. So we just need to substitute n with 2. Okay, RH is the Ribot constant. So the formula with the negative, so you need to put that in. So this is the Ribot constant. So now it is at the second orbit, energy level n equals to 2. So substitute in, and this is basically the energy of the electron when it is at the second orbit or second energy level. So now my first question. Okay, so how about now the electron at the third orbit? Okay, so third orbit. So what is the energy of the electron when it is at the third orbit with energy level n equals to 3? So, okay, so I give you 30 seconds to calculate, Mary. Any answer from the students?
Not yet. Okay.
Not yet. Okay. So now the electron is at the third orbit, which is equivalent to energy level n equals to 3. So what would be the energy of the electron when it is at the third orbit? Energy level n equals to 3. Any answer from the students?
Yes. Okay.
Okay.
Aina Maisara, negative 2.42 times 10 to the power of negative 19 joule. Pang Kersin giving the same answer. Shamimi Auni also giving the same answer.
Okay, so that is A. Okay, so that is A. So negative 2.42 times 10 to the power of negative 19. Okay, very good. So and so on. Okay, so if it is at the fourth orbit with energy level n equals to 4, you also do the same thing. Okay, so basically this is the energy of electron when it is at that particular orbit. When it is at that particular orbit. Okay, so it has this energy because of the orbit itself having certain amount of energy. Okay, so and the electron be in that orbit, it has that particular amount of energy, and because of that, we say the energy of electron is quantized. So we can see that. Okay, so just now we have done the calculations for the electron at n equals to 1, n equals to 2, and n equals to 3. And we can see that when electron is at n equals to 1, the energy of the electron is the most negative, So basically, when the energy most negative means that the electron is at the most stable state. So the whole atom, hydrogen atom, is at the most stable state. Okay, and basically when the electron is at n equals to 1, lowest energy state, it is at the lowest energy state, and we call n equals to 1 the ground state. Okay, so again, n equals to 1, the most negative, so means that electron most stable and the hydrogen atom most stable. And when electron is at n equals to 1, we said that the electron and the atom is in ground state. Okay, most stable state, ground state. So, and then as the n gets larger, so this is n equals to 2, n equals to 3. So as the n gets larger, we can see that the energy become less negative. Okay, or in other words, energy increases. Okay, so basically, when electron is at any energy level higher than n equals to 1, be it at n equals to 2, n equals to 3 or higher, we call that electrons to be at the excited state. So basically, excited state refer to energy, any energy level that is higher than n equals to 1. Okay. So, okay, we move on to look at the third postulate. So for the third postulate, so just now I told you that Bose met three postulate when proposed the hydrogen atom atomic structure model, atomic model. Okay, so the third postulate is he said that the electron move between allowed orbits. Energy of photon is absorbed or emitted. Okay, so means that electrons, when want to move between orbits, between energy level, okay, that particular electron need to absorb energy or emit energy in terms of photon. Okay, so why? Okay, so just now I told you already, madam, at first is at the second step. Okay, so second step of the staircase. Okay, so if madam now want to move to higher step, so if want to move to fourth step, okay, so basically I need to madam has fat. Okay, so I need to burn my fat, change it to kinetic energy, then only madam can move to higher step, higher energy level. Okay, and when at higher energy level, if madam want to go back to step number 2, then I need to lose my gravitational potential energy to convert it to kinetic energy in order for me to move down. Okay, so want to move to higher energy level, I need to gain kinetic energy from my fat so that I can move to higher energy level. So when from high energy level, I want to go back to lower energy level, I need to lose energy, okay, so that can convert to kinetic energy for me to move down. So as electron, okay. So but then electron, not like madam has fat, can convert to kinetic energy. So electron does not have fat. So where does the electron get the energy from in order for it to move to higher energy level? So it basically need to get the energy from outside, okay, in terms of photon. So basically it need to get the energy from the photon. You need to absorb the photon in order for the electron to move to the higher energy level. So you can see from the animations here. So the electron at first is at n equals to 1. So want to move to higher energy level, so photon need to be absorbed, okay, in order for the electron to move to higher energy level n equals to 2. And at n equals to 2, higher energy level, the electron is not stable, so it will move back to lower energy level. So when move back to lower energy level, so again, photon will be emitted. Okay, so that is the third postulate. Okay, electron moving between the orbits. Okay, so to move up to the higher energy level, so you need to get the energy from the photon. So you need to absorb the energy from the photon in order for the electron to get energy, move to higher energy level. So at higher energy level, it is not stable, electron is not stable. So want to move back to lower energy level, you need to emit the photon. Okay, you need to emit the photon. And then one thing you need to know is the movement of the electron between orbits or between energy level. We call this as electron transition. Okay, so the movement of electrons between energy levels or between orbits, we call that as electron transition. So basically, electron transition moving between orbits or energy level require photon to be absorbed or emitted. Okay, so and the energy of the photon that need to be absorbed or emitted basically is equal to the difference in energy between the two energy level, just like Madden just now. Okay, so if I want to move to from step number 2 to step number 4, okay, so step number 2 to step number 4, so how much kinetic energy I need to have? So basically, I need to have the kinetic energy equal to the difference between the the kinetic energy I need to have is basically equal to the difference in the potential, gravitational potential energy between the two steps. Okay, so as the electron, so in order to move between the energy level, how much energy from the photon you need to absorb? Basically, it need to be equal to the energy difference between the two energy levels. So for the energy of photon, we can calculate it using the formula So using this formula, okay, where the H here is the Planck constant. So this is, Planck constant is a constant. So this is the value 6.63 times 10 to the power of negative 34 joule second. Okay, so you don't need to remember this constant because the constant table, I think you have it already. So you just need to refer to the table. Okay, and then the new here is refer to the frequency. Refer to frequency. Okay, refer to frequency of the photon. Okay, and then if we are being given frequency, if we want to know what is the wavelength of the photon, we can use this formula to calculate the wavelength of the photon. And what is the C here? C here is the speed of light in vacuum. So speed of light in vacuum is also a constant. So you don't need to remember, it's also in the table. So 3 times 10 to the power of 8 meter per second. So you just need to put the constant in to do the calculation. So besides that, if you know, yeah.
Okay. Let's stop for a while for advertisement.
Oh, okay,
Thank
okay.
you.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Hi students, welcome back. Now I would like to announce another passcode, which is 7. 7. 7. Okay, let's continue our lesson with Teacher Tang. Hi Teacher Tang, you can continue.
Okay, thank you, Teacher Con. Okay, so and then if we are having the wavelength of the photon, we also can determine the electron transitions between which two energy levels. Okay, so and this equation we call it as Rebut equation. Be careful with this equation. This is to calculate the wavelength of photon, and then the RH here is also Rebut constant, but because this one is to calculate the wavelength, so the Rebut constant here having different value than the previous one. Okay, so this is another Rebut constant in the Rebut equation used to calculate the wavelength of the photon. Okay, so the Rebut constant, the second Rebut constant to calculate the wavelength of photon is 1.097 times 10 to the power of 7 per meter. So just now I told you that the energy of the photon must equal to the energy difference between the two energy levels. Okay, so therefore, if we know the energy of photon, so the energy of photon magnitude will be equal to the change in the energy or energy difference between the two energy levels. So if we know the energy of photon, then we know the difference in energy between the two energy levels, then we can also determine the electron transition between the energy levels. Okay, so for this formula, because this is difference in energy, so the Rebut constant here, therefore, will be 2.18 times 10 to the power of negative 18 joule. So you just need to look at the unit. For the joule, is used to calculate the energy. If per meter is used to calculate the wavelength. Okay, so now we move on to look at how to use all these formula. So I have introduced 5 formulas to you. So the first one, second, third, fourth, and the fifth. Okay, so we have looked at the first one. This is to calculate the energy of electron at a particular orbit. do not involve electron transitions. Okay, but the rest of the formula, the other four, these four formula involve electron transitions. Okay, so if you want to do calculation, you need to ask yourself whether involve electron transitions or not. Okay, so if involve electron transition, definitely not formula number one. Okay, so to do the calculation, basically, usually I will teach students to follow through these 3 steps. So step number 1, we list out the informations first. Then step number 2, you choose appropriate formula. Okay, from all the 5 formula, you choose one. Okay, so how to choose? You need to choose based on informations that are given to you and what you want to find. Okay, and then step number 3, you just substitute all the information into the formula that you chose to calculate the final answer. So shall we look at example 1? So in this example 1, okay, we are being given the frequency of the photon. So the frequency of the photon. Okay, so and then we are being asked to calculate the energy of the photon. Okay, so that is step number 1. We list out the information that have been given to us. Okay, so and then step number 2, we choose the formula. So which formula involve energy of photon and frequency? So that is the formula number 2. So therefore, we need to choose the formula, appropriate formula. And then what we need to do next, we just need to substitute. So H is the Planck constant, is a constant. So we just need to substitute the constant with the frequency into the formula. Then we get the answer. Okay, so very easy. So 3 steps for you to get the answer. So we move on to look at the second example. So now you are still being given frequency, but you are being asked to find wavelength. Okay, so based on the information that you have, now you need to choose a formula. Can you see that? This is the formula that you need to use. Okay, because this is the formula with frequency and the wavelength. Okay, so and then C is a constant, speed of light. So you can just put that in. So then you get the answer. Okay. So example 3. So if we are being given, okay, so this is energy level. So electron makes a transition from n equals to 4 to n equals to 1 and asks us to calculate the wavelength of the photon. So we have electron transition, n equals to 4 to n equals to 1. We want to calculate wavelength of photon, So which formula to choose? So can you see that? So here, this is electron transition. Okay, so between which energy level to which energy level, and we want to calculate the wavelength of photon. Therefore, this is the formula that we need to use. Okay, and then for this formula, you need to be very careful because the formula defines that N1 must be smaller than N2. N1 must be smaller than N2. So we have 2, N4, N equals to 4 and N equals to 1. So which one is smaller, N equals to 4 or N equals to 1? Can you see that N equals to 1 is smaller than N equals to 2? So therefore, N equals to 1 should be your N1. Okay, and N equals to 2 is your N equals to 4. Okay, so after determining this, we just need to put into the equation. So this is the Rebut constant. So for wavelength, so this is the Rebut constant. So we just need to put in. Then we get the wavelength of the photon emitted when the electron making the transition from n equals to 4 to n equals to 1. So another example, example 4. So again, involve electron transition. Okay, n equals to 4 to n equals to 1. And then now we want to calculate the energy of photon. Okay, we want to calculate energy of the photon. Okay, so can you see that we have the electron transition between the two energy level? So we have this. Okay, and then we want to calculate energy of photon. Okay, so therefore this is the formula that we need to use. Okay, for this formula, it is different from the Rebut equation for wavelength. Okay, so for this formula, it is n initial and n final. Means that n initial refer to the initial energy level. So when the electron makes a transition from n equals to 4 to n equals to 1, so means that this is the initial energy level. So n equals to 4. So electron at first is at n equals to 4, and then it fall to n equals to 1. It fall to n equals to 1. So this is initial energy level. This is the final energy level. Okay. So with that, we then can substitute into the formula. So again, this is energy. So the Rebut constant should be 2.18 times 10 to the power of negative 18 joule. So, and then we will get negative. This negative, we know that energy is a scalar quantity, so have no direction. So basically, this negative means that the photon is emitted, means that the electron, when it moves from n equals to 4 to n equals to 1, so it emits photon. Okay, so it emits photon. Okay, so photon is emitted, that's why it's negative. Okay, having the negative in front. Okay, but the energy of photon, we know that the energy is scalar quantity, shouldn't having direction. So we just write this. Okay, we just write the magnitude of it. Okay, because it has no direction. This negative is just telling us that when the electron move from higher energy level to lower energy level, okay, so photon is emitted. Okay, photon is emitted. So now question number 2. Okay, so what is your answer for question number 2? Okay, so to do this question again, follow the 3 steps. So step number 1, look at what is being given to you. So we are being given, so electron makes a transition from n equals to 5 to n equals to 2. So this is electron transition. Okay, and then we want to determine the wavelength of the photon. Okay, we want to determine the wavelength of the photon. So we have 5 formula. So which formula we should use in order to determine the wavelength of the photon? Okay, and then you calculate what is the wavelength of the photon. Yeah, I give you maybe 30 seconds. So any answer from the student?
Yes, there are few student answer. Okay, from Shamimi Auni, the answer is A.
Okay, A. So shall we see what is the answer? So, okay, so electron transition, so means that we need to use the 5th formula. Okay, so again, be careful with this. So N2 must be larger than N1, so means that this is N equals to 5, N2 is N equals to 5, and N1 is N equals to 2. So you substitute in, then you get the answer as A. Very good, very good. So shall we move on to look at the next question? So now we want to determine the energy of photon needed. for an electron makes the transitions from n equals to 2 to n equals to 5. So again, so first, list out what is being given to you. So you are being given the electron transition between the energy level n equals to 2 to n equals to 5, and you want to find the energy of photon. So out of these 5 formula, you choose one first. Okay, which formula you need to use to calculate the energy of photon. You are being given the electron transition between the energy level. Oh, I forgot to give you the, okay, so which answer? Any answer from the students yet?
Okay, that's it.
Not yet. So again, you choose the appropriate formula first. Okay, you choose the appropriate formula, then only you calculate the energy.
Okay, again from Shamimi Auni, her answer is C.
C. Okay, so any other answer?
Amira Sophia, D.
D. Okay, so shall we see?
Danish Hakim Fauzi, D.
Okay, good. So we know that this is the equations we need to use. So again, for this question, initially the electron, you see, initially it is at n equals to 2. So initially electron is at n equals to 2. And then it make a transition to n equals to 5. Okay, so at the end, electron is here. So this is initial and this is final. So we know that when madam need to climb to higher energy level, so the electron need to gain energy. So gain photon, absorb photon. So with that in mind, okay, so you have this, you substitute into the formula. Okay, so with that in mind, when moving out, energy need to be gained. Okay, you should get a positive value. Okay, so positive value basically means that the electron, the photon need to be absorbed by the electron in order for electron to move to higher energy level. So therefore, the answer is D. When here you get negative, means that electron from higher energy level move to lower energy level, therefore photon is emitted. But now move to higher energy level, from lower energy level move to higher energy level, photon need to be absorbed, and when photon is absorbed, here you will get a positive value. Okay, but energy of photon, it is a scalar quantity. So there's no positive or negative in terms of energy. Okay, so this is the value, this is the answer, okay, D. So shall we move on? So what I told you just now, this one all involve one hydrogen atom, and therefore involve only one electron. Okay, because we know that in one hydrogen atom only have one electron. But then life will be very, very boring if we just study about one hydrogen atom, right? So in experiment, not possible for us to just put one hydrogen inside and then we study about that. No, not possible. So usually in the experiment, scientists will use hydrogen molecule. So of course they will not put one hydrogen molecules in it. Okay, so usually they will put moles of hydrogen molecule. So for example, if they are putting 0.5 mole of hydrogen molecules, means that it is equivalent to 3.01 times 10 to the power of 23 hydrogen molecules. Okay, and that is equivalent to, and this is equivalent to 6.02 times 10 to the power of 23 hydrogen atoms. Okay, if we are putting 0.5 mole into the discharge tube to do the experiment. Okay, and that is also equivalent to 6.02 times 10 to the power of 23 electrons, okay, inside, okay. So basically, what scientists did is they put the hydrogen molecule inside the discharge tube, and then they see the discharge tube glows. Okay, so means that light is being emitted. Okay, photon is being emitted. Okay, and when the light, okay, from the discharge tube pass through the slit and pass through the prism, the scientists observe this, and this is what we call as hydrogen emissions line spectrum. Okay, so hydrogen atom emissions line spectrum. Okay, where we see discrete lines like this. Okay, and we call this as emission line spectrum of hydrogen atom. Okay, so now we are going to see how to form this hydrogen emission line spectrum. Okay, so at first we put the hydrogen molecule into the discharge tube. Okay, before energy is being the voltage is being applied. Before voltage is being applied, all the electrons, they are in ground state, n equals to 1. So they are in ground state. Okay, I couldn't draw 6.02 times 10 to the power of 23 electrons, so I just draw few. Okay, a few. Okay, so at first all the electrons are in the ground state, n equals to 1. Okay, when voltage is applied, so first hydrogen molecule, they break down, become hydrogen atoms. Okay, break down, become hydrogen atoms. And then when the electrons gain energy, absorb the photon, so the electrons gain energy, absorb the photon, they will move to higher energy level. So shall we see the animation? So the electron at first at n equals to 1. Okay, absorb energy, they will move to higher energy level like this, higher than n equals to 1. Okay, so higher than n equals to 1. So at high energy level, so they are not stable. Can you see them wobbling? Okay, so they are not stable. So what will happen is they will fall back to lower energy level. So fall back to lower energy level like this. Okay, when fall back to lower energy level, they will emit photon. They will emit photon like this. And this photon emitted will have specific energy, wavelength, or frequency. Okay, which causes the discrete line to be formed on the line spectrum. It's because this photon emitted having specific amount of frequency, wavelength, or energy. That's why when passing through the prism, it will give discrete line like this on the line spectrum. Okay, and then basically when electron from higher energy level fall back to n equals to 1, and emit photon, and this photon emitted will have the frequency, okay, will have the frequency in the ultraviolet region. Okay, and then will give Lyman series. Okay, so again, electron from high energy level fall back to n equals to 1. So the photon emitted will have energy in the ultraviolet region and give rise to the Lyman series. Okay, if the electron from higher energy level drop back to lower energy level, n equals to 2, then the energy emitted by the photon emitted will have the energy in visible light region, and that will give rise to the Balmer series. Okay, and then if higher energy level drop back to lower energy level, n equals to 3, then the photon emitted will have the energy in the infrared region, and that will give Paschen series. Okay, and then if the electron from higher energy level drop back to n equals to 4, okay, the photon emitted again having infrared region, having the energy in the infrared region, and that will give rise to the bracket series. Okay, so and then if from higher energy level drop back to n equals to 5, the photon emitted will have the energy in the infrared regions as well, and that give rise to the P-fan series. Okay, so how to remember Lyman series, Balmer series, Paschen bracket, P-fan? So Lyman corresponding to higher energy level, jatuh to n equals to 1. Balmer series, higher energy level, fall back to n equals to 2. Paschen, higher energy level, fall to n equals to 3. Bracket, higher energy level, fall to n equals to 4. P-fan, higher energy level, fall to n equals to 5. Okay, so how to remember this? I always remember Lyman, balik, pasar, bawah, pisan. Okay, so that you know how to remember the series. Okay. So Lyman series, higher energy level, fall to n equals to 1. Okay, so the first line in the Lyman series, so this is the first line in the line spectrum, is corresponding to n electron from n equals to 2 jatuh to n equals to 1. That give rise to the first line in the Lyman series. So second line corresponding to n equals to 3, fall to n equals to 1. Okay, so third line corresponding to n equals to 4, fall to n equals to 1. So fourth line corresponding to n equals to 5, fall to n equals to 1. So Lyman series, all from higher energy level, fall to n equals to 1. Okay, so for Balmer series also, higher energy level, fall to n equals to 2. First line corresponding to N3 to N2, second line N4 to N2, third line N5 to N2, okay, sixth line fourth line is N6 to N2. Okay, so Balmer series, higher energy level to n equals to 2. Okay, to n equals to 2, and so on. Okay, Paschen series, higher level to n equals to 3. Bracket series, higher energy level to n equals to 4. P-fan series, higher energy level to n equals to 5. Okay, so my last question before I finish the class. Okay, can you tell me how to form, so electron transition, okay, to form, okay, second line in bracket series. Okay, so how to determine the electron transition to form second line in the bracket series? Okay, okay, so this is your question before I finish the class. So determine the electron transition forming the second line in the bracket series. Okay, so I give you a clue. So first you need to ask yourself, bracket series corresponding from higher energy level drop to where? So bracket series, we know that it dropped to n equals to 4. Okay, so means that, so n, okay, so it need to drop to n equals to 4. So if a second line, so means that it need to drop from where in order to give you second line in the bracket series? Any answer from the students? So the second line corresponding to electron transitions from where to where? N equals to what? To n equals to 4 in order to give you second line in the bracket series. You can also look at the bracket series? So any answer from the students?
Okay, not yet. But this is the next class code. Oh, yes. Okay, one of the students give the answer already. N equal to 4 to n equal to 6 to n equal to 4.
Oh, very good.
Jacinta
That
also
is
give
correct.
Yeah, Jacinta also give the same answer. Yeah.
Okay, good, very good. So before I finish, okay, let me tell you how to determine this. So this is my way to determine this. Okay, so this is higher energy level. So higher energy level is equal to lower energy level plus the number of the line. Okay, like for this question, bracket series, we know that it need to fall to n equals to 4. So therefore, the lower is n equals to 4. So the lower is n equals to 4. So it is second line. So plus 2. So therefore, it need to fall from higher energy level, n equals to 6 to n equals to 4. So you just need to remember this way to determine it need to fall from where to where to give you which line in which series. Okay, so the line, okay, is given in the question. The lower energy level you determine from the series, and you just need to determine the higher energy level where the electron started to fall. Okay, so that's it from me today.
Okay, thank you, Teacher Tang. Okay, class, the last class code is 6 and 7. 6 and 7. 6 dan 7. Okay? Okay, with God's grace, we are done with today's section. We have learned a lot from Teacher Tang about atomic structure. Congratulations to those who are able to follow our section from the beginning till the end. And thank you very much, Teacher Tang, for such an interesting lesson. Before I provide the certificate link, please check the chat box for the certificate link. And please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to Teacher Tang for giving you a free lesson today. Don't forget to click the bell button too so you won't miss out any new videos and live classes from Teacher Tang. If you like today's lesson, please click like and share it to your social media friends. Let's share the knowledge you received today with them. Sharing is caring, right? When you are finished, type done in the chat section. Then I will give you the certificate link. Once again, I would like to thank you, Teacher Tang, for the interesting lesson. Thank you also, Sir Shannon, for being with us today. I think that's all for now. See you all in another section. Please remember, stay at home. Goodbye, everyone. See you all again next week. Bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.